Okay, we're going to take a look at our ground detect lab, our ground detect light lab. And in your lab, you're going to see that you've got a bunch of these diagrams right here. Let's just figure out what this diagram is, by the way. We have the secondary of a transformer. It's fused because it's ungrounded. You learned that if it was grounded, there would be a ground on the coming off of this side, and that we would only need one fuse, but we have two because it's ungrounded. It looks like we have a stop, start, control relay with memory. So this is our holding circuit. And if we push the start, we're going to get memory. And it looks like this would close and this would close, and that a light would come on. Okay. What we also have on here is the ground detect lights here, with this E signaling that this is a common point for the cabinet that this would be enclosed in. Okay. So if I go and I take a look at the unit, this is kind of a built-up unit like that, okay? And so what we have is our transformer here, and it does go to a couple of fuses, transformer to fuses. That's what that said right there. The transformer was going to be going to one fuse, two fuse. And then it's got a start-stop here. Here's my ground detect lights. I'm turning on a relay over here, because it's got a control relay, so that's where my memory is coming from. My holding contacts are right here. And then my goal is to turn this light on right here. So what we're going to do right now is I'm just going to turn it on. There's a little power to that. And first thing I want you to do is notice these lights over here. Okay? Did you see that those lights are dim? This light is dim here, and this light is dim here. Okay? What I'll do is I'll shut the power off again to see if you can see that this light goes a little bit dull. Okay, so these lights, there's power back on, are coming on dim. So let's check the operation of the circuit. If I hit the start button here, I'm going to get control relay, I'm going to get memory, I'm going to get this light to come on. This control relay is on, this light's on. These lights remain dim. When I shut it off, this light went off, these lights remain dim. Okay, so that's the way that this circuit that I've got hooked up here is essentially this circuit here. Okay, so now what this lab is going to be asking is, you know, what is going on, and I want you to use the highlighter for this. What is going on when when each case, a ground fault point, no connection, no push buttons pressed. That's situation one. This is the very first one. So if I look at this right now, I want you to draw the path from rail to rail of where this current is flowing. So if we look here, you got to be continuous. There's no current flow through here because we have not pushed the button. There's no current flow through here because there's no holding contact. These lights are dim. So that means that there is current flow through here. So you would take your highlighter and you would put current flow through there. And then there is no other current flow. Okay? Now, I believe the next one asks, start push button is pressed and held. So when I press and hold the start button, which is right here, first of all, we're going to see what happens to these lights. It looks like these lights haven't changed. The control relay is on, and the light is on when it's held like that, okay? So I went to the second one, and when the start button was pressed and held, we were getting current flow through here, and I suppose we were getting current flow through there as well, because that control relay was on. We were getting current flow through here because both of those lights were dimly lit, and we were getting current flow through here because that light was on. So your goal is to come through here and take a look at these and see if you can figure out where the current flow will be once the condition is met. I think the next connection is when you release the start button. So when you release the start button on the next one, the current flow would only be through here, and through here, because we would have memory. We would no longer have current flow through there. Okay, so you got to go and analyze each case carefully. I would draw it in with a pencil, and then I would get your highlighter and draw where the current flow is. Now, it gets a little more complicated than that as we go on to some of the more complicated situations. So, for example, when we have the situation C, okay, we have a ground fault to point C. So we got points A, points B, point C, point D. Either one of these would be F. Either one of these would be G. So this says that there's a ground fault to C. And so here's my ground fault point. So I would have a connection across here. Okay? So you would draw it in with a pencil and try and figure out what's going on. So what I'm going to go ahead is I'm going to take my ground fault right here, because this is essentially my E, and I'm going to plug it into this one right here because this says C. Okay? And I'm going to unplug it again. Did you see what happened over here? I'm going to unplug it. I got the dim lights. When I plug it into C, I get one light on there. Okay? And so now I want you to draw the current. Well, this looks good here, except I haven't pushed the start, so the control relay is not on. So obviously there's no current flow through there. But I have the left light on. So why is that? Well, the current flow goes through that light. It goes through the ground fault, and then goes through the control relay like that. And we learned that when you put a light and a control relay in series, the control relay doesn't drop very much voltage, even though we talked about the difference between DC and AC. We kind of modeled this with Ohm's law. It would be different, but basically this is not getting enough voltage. Most of the voltage drop is coming through the light, and therefore this light is on. This light is off, because if you're going to do the path of least resistance, we learned that this has a lot more resistance than the control relay. So the electricity is not going to want, not very much is really going to want to go through that light there. Most of it's going to kind of take this path here, and instead of having this half on and this half on, the electricity goes this way, and then we get the drop there. There's no electricity here, etc. And then you would work through the lab. I think the next one says press and hold the push button, and now you'll see that this light's off and that one's on, and then there's items on, and you're going to want to go through and try and figure out, based on these drawings and being intuitive, of how you think the current's going to flow. Draw it with a pencil. So example, if they said that there's a fault to A, you would draw the line to A. If there is a fault to B, you would draw the line to E. If there's a fault to F, you would draw the line to here. And there's a fault to G, it would be somewhere onto there. And you will try and figure out what each of these will do. So that's this lab. Take a look at it, and then we'll review the answers at a later date.